Alright guys, so this is the last video, so I'm going to try and make it quick, especially because I know the other video was really long. I did find the typo in number 8. The denominator should have been a negative 1/2, which would have changed your signs, which you would have divided by something else. So number 8 was off, so you can just kind of cross it out, and we can talk about it in class. So sorry about that. Okay, the last thing we have to talk about is an infinite geometric series, okay? Which means that you add them up forever. That means they just keep going and going and going. It says the series usually states that an infinite geometric series is an infinite geometric series, or it has dots, okay? Infinite obviously means that it doesn't stop. It just keeps going and going and going and going. So this is the formula. It's on your formula sheet. It's the very, very last one, bottom right, down there. It's very simple. It does have the infinity symbol so that you know it's infinite. But the key is that the ratio its absolute value cannot be less than 1. And what that means is that the ratio, what we're multiplying by, must be a fraction. Okay? Because the numbers have to be getting smaller and smaller and smaller. Okay? Because the way that you can add something up infinitely on forever is that they get so small that it's almost like you're at 0. So that's why we can do it. If the numbers just keep getting larger and larger and our ratio is just a regular number and we just keep doubling or tripling or whatever, then it's never going to stop. It's just going to get huge and huge and huge, and you can't add that up for forever, okay? So it has to be a fraction, okay? If it's not a fraction, if the ratio is not a fraction, then you're done. You don't even have to do the problem, okay? So, let's look at these problems. I'm going to scroll some. That way, we can get a bunch of them done. Okay? So, let's look at these. All right. And by the way, I'm sorry, this is page 6. It is page 6 where it says infinite geometric series, because I want us to do those practice problems in class. So, so you do skip a page into page 6. So you still just want to list what you need. You need the sum, you need the first term, and you need the ratio. Those are the only 3 things you need because it just keeps going forever. So the sum is what we're finding. The first term is 10. But in this case, we're multiplying by 2, by 2, by 2. We're multiplying by 2. Well, always double check this. Is this a fraction? Okay, nope, it's not. So this has no sum. It has no sum because they're getting too large. They would go on forever and just get larger and larger, and you can't add that up. Okay, so then the next one. We want to find the sum. We need the first term, and we need the ratio. Okay, so the first term is 40. And the ratio, it looks like we're dividing by 2. Okay, well, dividing by 2 is the same thing as a half, or multiply by a half, or 0.5. So let's put it into the formula. It is the first term, which is 40, over 1 minus the ratio. Now I'm going to use 0.5, just it's easier than having a bunch of division if you want to do it all at once. So that's the sum equals 40 divided by 0.5, or divided by 1/2, which you could keep, change, flip, but we won't. Which is just the number 80. If you want to use your calculator, it just gives you the number 80. Okay? So again, it's a pretty quick formula if you recognize that the ratio is a fraction, and then you're just careful as you put it into the formula. Okay? So let's look at the other ones. again, always double check the fraction and then just go from there. So let's do, sorry, I'm looking for a marker that I know shows up well. Okay, so we want to find the sum of the infinite, the first term, and the ratio. Okay, so the first term is 5. And in this case, the ratio is kind of weird. Let me write it off to the side real quick. 5, negative 10 thirds, positive 20 ninths. So it's definitely negative because it's going positive, negative, positive. And it's something about a third because we've got a third here, and then 3 times 3 would give you 9, and so forth. And then when I look at the numerators, 5 to 10, 10 to 20, looks like I'm multiplying by 2. Okay? So what I did was I just compared my numbers. I saw the positives and negatives. I saw that a 3 started showing up in the denominator, and then I noticed that the numerators were doubling, so that's why it's 2/3. Okay, so it is a fraction, so I can now use my formula. So the sum is 5 over 1 minus negative 2/3. Negative 2/3 from there, minus from there. I'm not going to change that to a, well, I'm not going to change that to a decimal because it would not be a good decimal. 1 minus, oops, I pushed the wrong button. 1 minus negative 2/3 is a fraction still, 5/3. Okay, and remember, when you divide by a fraction, you could say keep, change, flip. So you could say 5 times and flip that, 3/5. The 5's cancel, and you get the number 3. If you don't want to do it that way, that just kind of takes us back to last unit. You could just say 5 divided by, with parentheses around your fraction, 5/3, and you'd still get 3. So whether you use a calculator or not, it'll still work out for you. Okay, number 4. Again, we're looking for the same 3 things, the sum, the first term, and the ratio. The sum is what we're looking for. The first term is 2. And the ratio, it does look like it's getting smaller. That's good. It's going positive, negative, so that means it's a negative number. And it looks like they're getting cut in half, so it's 1/2. Okay? So that is a fraction. We're good. So let's use our formula. Equals first term 2 over 1 minus negative 1/2. Again, that's what I made the mistake in, was that it's a negative 1/2. So the sum is 2 over 1.5, because that would be plus 1/2. And 2 divided by 1.5 is a fraction. 4/3. Alright, because that would be 2/3, and then if you keep, or excuse me, it'd be 3/2. If you keep change flip, it would flip the fraction over to 4/3. Well, that's how you get in the end. Okay? Alright, number 5 is a little bit faster than we might think, because if you list the 3 things you need, the sum is what we're looking for. The first term is 15, but our ratio is 2, which is not a fraction. So there is no sum for this one. Okay? So don't forget about that fraction rule, because it'll make it a lot faster. Okay? So now let's finish out by looking at this one. Alright, and the way we know it's infinite is because there's an infinity symbol. So that's what we're looking for. The first term and the ratio. The first term is the number in front, usually, and the ratio is the number inside, or the one with the power. So the first term is 2, and the ratio is 1/2. So the ratio is good. So let's just put it into the formula. 2 over 1 minus a half. So that is 2 over a half. Again, you could divide that in your calculator. You could divide by 0.5. I know that that's keep, change, flip. So if I flip that 1/2, that's actually just the number 4. So it's actually faster for me to go ahead and just keep, change, flip because I'm so used to that rule. But it gives you the same thing. If you want to say divide by 0.5, divide with fraction, half, then that you can do it anyway. But you get 4 regardless. And this symbol meant series or sum. And that infinite symbol helped us know that's why we turned to that formula. Okay? And don't forget the first number is your first term, and then the number with the power, that's always the ratio. All right, so that's it. Okay, guys?